So this video is on solving equations, specifically more than just like a single step or a two-step equation, more complicated equations. Still pretty consistent in that your goal is to solve for the variable. So we talk about isolating the variable, which means getting the variable alone on one side, the constant on the other side. Or sometimes I like to think of it as what plus or minus 0 equals whatever. So I'm looking for on the left side or on one side or the other, just one x and nothing else. Remember, balance. Whatever you do to one side of the equation, you must do to the other side of the equation. You can't just willy-nilly subtract something unless in an equation you're subtracting it from both sides because that's keeping it equivalent. It's keeping that equal sign true. So I talk about, those are the two rules. The 5 tools for more complicated equations is these italics. Otherwise, you get down to just the standard stuff. But I'm going to start with the more complicated ones because that's what these examples are. So first, simplify each side of the equation by distributing and then combining like terms. So when I talk about, we're going to use this example here, sides of the equation, I like to just draw a line down where the equal sign is. Then I'm not going to start out by getting this as simple as I can and this as simple as I can. Well, this is pretty simple already. But over here, what can I do? What can I do to simplify this? Well, I have 6u and I have negative 9u. So I can use the commutative property and say 6u plus negative 9u and then still plus 18. So I'm just moving things around. I can do that because they're all addition as long as I say it's plus a negative 9. Then I can combine these two. So 6u plus negative 9u or 6u minus 9u gives me negative 3u. Because 6 of these positives canceled out 6 negatives, leaving me with 3 negatives. I still have the 18, and over here I still have negative 12. That's the equal. Now, I'm going to go back up here. If there are variables on both sides, well, there aren't. There's only a variable on one side. So then I just go to using the inverse identity of addition. So the inverse of addition is subtraction. So instead of adding 18 to this, I'm going to get rid of it. I'm going to turn it into 0 by subtracting 18. If I subtract 18 here, I have to subtract 18 here. Positive 18, negative 18, that becomes a 0. So I basically have negative 3u plus 0, but I don't write the 0. Equals, I have negative 12 minus 18. Well, however you look at that, whether you're combining a negative and a negative, so you're adding them together, or if you say this is plus a negative 18, I'm adding together a negative 12 and a negative 18. I'm combining them. It stays negative because they're both negative. I have 12 of them and 18 of them, so altogether I have 30 of them. Then, because this is multiplied, I'm going to divide. Because negative 3 divided by negative 3 gives me a 1. That's what I want. I want 1u. So I have just u left here. But if I divide on this side, always write it on both sides at the same time so you don't forget. I have negative 30 divided by negative 3. Well, negative divided by negative is positive. 30 divided by 3 is 10. So I have u equals 10. My last rule is, don't be a fool. Check your answer by plugging it in for the variable and simplifying. Get the answer, make sure it's right. I can do that with equations. Because I can go back and I can say 6 times u, well, if u is 10, plus 18, and I'm running out of space here, minus 9 times 10, minus 9u, so 9 times 10 is supposed to equal negative 12. Because it equals negative 12. 6 times 10 is 60, plus 18, minus 9 times 10 is 90. So 60 plus 18 is 78, minus 90. The difference between 78 and 90 is 12. 90 is bigger, so it's negative. So yes, negative 12 equals negative 12. So that one checked. I'm going to go down and do this next one down here because it gets a little more complicated still. There's my two sides. That's about as simple as it can be. This one I can simplify because I can distribute. So I can say negative 6 times b is negative 6b. Negative 6 times 5 is negative 30. I can't simplify this anymore because those are not like terms. I cannot simplify this anymore because those are like terms. So now I want to get the variables on one side. If I add 9v here, I'll get 0. Or if I add 6v here, I'll get 0. I can go either way. Most people like their variable on the left side, so I'm going to go that way. You can do it the other way, you'll get the same answer. So I'm going to add 6v to both sides. So negative 9v and positive 6v is negative 3v. I still have minus 36. This became a 0, so now I just have negative 30. Now I want the variable by itself, so I'm going to deal with this. If I add 36 to negative 36, it becomes a 0, but if I add it here, I have to add it here. So I have negative 3b plus 0, so I'm not even writing that. Negative 30, positive 36. 30 gets subtracted from 36 because 30 negatives take away 30 positives, leaving me with 6 positive. I still want just the v, so I'm going to divide. So negative 3 divided by negative 3. Notice how I put the negative there so that it becomes a positive 1. I want a positive v. But if I do it here, I do it here. So I have v equals 6 divided by negative 3. 6 divided by negative 3 is negative 2. So v equals negative 2. And I can go back and plug that in and check it to see if I got the right answer. I can tell you I did. So there are two more problems here that you can practice with. That gave you sort of an example and something to work with. The answers to these will be posted in Blackboard with the handout.